Hello everyone. In this lecture, we will discuss about another concrete class, that is a stack. What does stack provide us? Stack provide us a way in which we can have last in first out access. So that generally is used when we are inserting in one order and extracting from the other way around. For example, or we are inserting in the same order, and the last element that has been inserted is the one that we are extracting out. So that provides us the way in which we can insert a bit faster. Retrieval is also faster. So this stack is primarily used for stack based languages and other concepts which are also used primarily a lot often in the practical life. Apart from the normal other methods, it allows us to push, pop, peek, empty, and search. These are some of the operations that are provided for the stack class, which also allows the collections to operate on them by pushing, popping, and peeking, and other things. So we can add a new item, we can remove the top of the stack, we can find out what is at the top of the stack without removing, and so on and so forth. So apart from array list, apart from linked list, we also are allowed to use stack. There is another way in which we can use collections framework, that is by the use of set interface. What is a set interface? Set interface allows us that we can have a concrete class in which there is no repetition allowed. So elements cannot be duplicate in this set. So they are implemented, the set interface is implemented primarily by hash set, linked hash set, tree set, and others. We will see in this short video about the hash set, but a similar way can be extended for linked hash set and tree set. A minor modification is there. So what is hashing? We already have seen in the previous interactions that hashing allows us to map a set of key value pair to a particular index. Now there is an array which is stored. We want to map the particular key, that is the index and the element, to a particular value where the searching or retrieval is absolutely fast. Suppose, for example, we have a short list that is having 10 or 15 or 20 elements. Now, in these elements, whether anyways in the array list, when we are extracting or when we are searching, it is in the order of 1. We just give the index and it is searched. If you want to find out, we find out in the sequential search. We will get to it within very less amount of time because the number of elements are less. Now, if the elements are 10, that's okay to use linked list for searching. But if the elements becomes 10 million, then the searching is very, very cumbersome by using traditional array list. Now, this solution is provided by the hash set. The hash set allows us to map in such a way that searching and retrieval is very, very fast, even in the presence of millions of elements in that particular list, in that particular hash set. So this hash set implements set interface, and there are other implementation details that are also provided. Apart from the normal functions add, contains, remove, and size, it also provides us the facility for handling the large number of sets as well. So let us see one example. So we can create an object of a hash set that we are using a generic in which we allow that set to have integer elements. And we add 5 elements: 12, 63, 34, 45, and again 12. Now the next 12 that we are adding is not added in one sense because it does not allow duplicate elements. When we are using iterator, we have seen in the last couple of videos, we have used iterator to iterate on that particular collection. Here we are using hash set. In this hash set, we are one by one we are traversing and finding out the elements which are there. Now, as you can see, there is no fixed order in which the elements are added in the hash set. They can be in any order. Now, when we are extracting them, we also see that the element 12 is not repeated. Thank you very much for your time.